Welcome to homework.
So the question was asking us, what is the wavelength of the light used? Okay, so for this question, so we know that in the double slit experiments, the minimum occurs at d sine theta, which is equal to m plus 1/2 lambda. So in this case, since the distance between two slits is much smaller than the distance from the slit to the screen, so the angle theta is really small. So if the angle theta is really small, we can just say sine theta is about equal to theta. Okay, so if theta is very small, so we'll get d theta is equal to m plus 1/2 times lambda. Okay, which will have theta equal to m plus 1/2 lambda over d. So also we can come up with another equation from this question. So if the distance from the minimum to the central fringe can be this can be given as y, so we'll get y is equal to d times tangent theta. And just like what I said, in this case, angle theta is really small. So tangent theta can be equal to theta. We'll get y just simply equal to d theta. Okay. So now we can plug in the theta from the first equation to the equation here, and we'll get y is equal to d times m plus 1/2 times lambda over d, the lowercase d. Okay. So if we was thinking about the difference, we can apply a derivative here, which will give us delta y is equal to d times delta m, because we're looking for derivative, so 1/2 is gone. Okay, times lambda over d, and then we'll have lambda is equal to delta y times d over d, the capital D, times delta m. Okay, and the delta y in this question is given as 18 millimeter, which is the distance between two slits. I'm sorry, not the distance. The distance between the first and 10th minima of a double slit pattern. Okay, and lowercase d in this case is the distance between the slit, which is 0.15 millimeter. Okay, and capital D is the distance from screen to the slit, which is 50.0 centimeters. So we can plug in these values. We'll get, let me see what's 18. Okay, so 18.0 times 10 to the power of -3 meter, since 1 millimeter is 10 to the power of -3 meter, times 0.15 times 10 to the power of -3 meters over 0.5 meter times delta m. So delta m in this case should be 9. Why? It's because the first minimum occurs at m equal to 0, and the 10th minimum occurs at when m equal to 9. So if you count it from 0 to 9, there are 10 difference of the integers, which is I'm sorry, it's 9 minus 0, so it's 9. Okay, so delta m is equal to 9. So we get just simply times 9, and this will give us the wavelength. It's about if you do some calculation, it's about 600 nanometers. Okay, because this can be equal to 6 times 10 to the power of -7 meter. And this is my solution for the question. Thank you.